the line in orange. Okay, so this is the file object from up here. sh open quotes is using a new feature of Scala 2.10, which in Rapture allows you to create a process very easily, and I'm piping from one to the other. So this will give us a process, and then I'm going to slurp that process, get characters out, and there is the correct source. Now, you might have noticed that we've got a very funny type here, which isn't the string that this appears to be. For now, I'm going to say, ignore that, it is really a string. And I'll explain why it is this complicated thing later. But for all intents and purposes, it is a string. So we can then parse that string.
John?
Yes.
We can't see that bottom
Up. Yeah, I will. So I'm going to parse this string. Now, you'll see there it's reformatted it, and we've got a very nice and straightforward string called JSON there. Now, normally with Scala it's a statically typed language, which means that the type system needs to know what types everything is, so that it knows whether it's safe to call a method on those types. JSON is the complete opposite of that. You don't normally know until runtime what types you have. But I happen to know that this JSON object contains a map with a value called fruits. So I'm going to say res5.fruits, and this is giving me the value fruits here, which is this subset. The compiler did complain that there was no method called fruits. It was happy to do that. And then I'm going to get the first element. So I just apply 0 to that. Notice that all the time this is still of type JSON. And then I'm going to get let's get the colour. And we've got green there. But this isn't a string yet. To get a string, I need to basically call get string, which will extract from the JSON the real value I want to work with. So there's no getting away from the fact that the Scala compiler does, at the end of a sequence of JSON lookups, it does need to know what type it's working with. But this is a string just like any other. I can get the length of it, for example. So that should be much easier than previous ways of accessing JSON using the standard JSON parser in the Scala standard library. So that's a very, very brief tour of a few of the features. So you've got some kind of idea of what I'm going to be talking about today. So why have I done this? Why have I worked on this library? Well, if you've worked with I/O before, you probably know that it always seems harder than it ought to be. Certainly with Java, and I'd written the same boilerplate code enough times that it became frustrating, and I decided to find a better way of doing it. So that's probably the main reason. But Scala gives us a lot more opportunity to use rich features and take advantage of more natural ways of writing I/O code. And we also want to generalize and unify ideas that are similar. So in Java, the API for accessing an HTTP URL is different from the API for accessing a file. But for most of the things we want to do, files or URLs, we ought to use the same method name, the same types. because that gives us familiarity, and it means we don't have to think about what particular kind of entity we're working with every time. This quite conveniently gives us less repetition. If we're reusing code as much as possible, we get drier code. Don't repeat yourself. It's more concise, and consequently, you tend to get fewer bugs with less repetition. And as a corollary of this, when you're extending a project, when you're developing a new feature, if you're from the programmer's point of view, what you want to do is specify only the bits that are different. You don't want to have to specify things that are that are already specified elsewhere. So that's quite a profound point, which is particularly relevant to Rapture. I'll show you a little bit about that later when I come to show you how to extend it to provide your own features if you wanted to.
So I have a question to the first bullet you showed about the Java APIs.
Yes.
There's written, let's say, that this is horrible to use. Let's say I have a question to maybe you encounter the Java API which is quite fine. Let's say not perfect but new to that.
Yes.
Or you could recommend something. I know that this meeting is about Scala, so you should not give any advertisement to Java. But if you could say something which is quite close to perfect, maybe not perfect, but perfect Java APIs for I don't know, JSON handling or something like that.
I haven't actually used Java itself in 6 or 7 years, so I'm probably not the best person to ask. If anyone else can answer the question, it might be useful.
So this is assumption only, yes, or some guess?
Well, it's assumption based on the Java standard library, which I do use through Scala, because it's
Scala language library does not have an I/O.
It has some I/O features, but it's incomplete, really. Yeah. Did anyone else have any questions? I want to make this quite informal, so if you do have questions, if I'm going too fast or something doesn't make sense, shout out. Okay, I'll move on to the next slide. So when designing the slide, I had a few priorities. I had a few things which were less important. So I wanted to make the API as clear and as natural as possible. I wanted to make it possible for other people to extend. And this comes back to the point of anyone extending it just defining the bits that are different. So it should be just a few lines of code to extend, depending on what you want to do, obviously. I wanted to have a rich and, I don't think I'll ever achieve a complete feature set, but to have a lot of features that are available from the outset. But this is a lower priority than having a good API that you can extend. The code code should be efficient. It should run quickly. But I'm not spending a lot of time yet working on measuring the exact speed of the method calls. That will come later, I hope, and hopefully there'll be work done to make sure that Rapture IO is as fast as using the other method. But at this stage, the focus is on these two items up here. And as a low priority, Java interoperability. The API, because I'm using so many rich features of Scala, I'm sure it will be almost completely unusable from Java, but you could if you really wanted to. So I'll talk through some of the concepts that are involved in Rapture IO. Some of the resources. Now these can do lots of different things. So they can be paths. Path is something that's basically a set of slashed strings that you can navigate. URLs, so HTTP URLs, HTTPS URLs, FTP URLs. A resource can be a URI. So it's a very, very general concept. Links, files can be on the file system. It can be a resource in the Java class path. Now some of these are combined, so a URL is also a path. It generally follows a path structure. Likewise, files are paths. TCP socket is a resource. Processes, or these aren't part of Rapture IO, but FTP, WebDAV, Amazon S3, or any other cloud service. These can all be resources. And the resources, the meaning of a resource will hopefully make sense when I talk about some of the capabilities that you can apply to a resource. So, on this slide. I think these slides are in the wrong order. Capabilities. So one thing you might want to do for a resource is to get an input stream or output stream from it. So that makes sense for a file. You can read and write from a file. Additionally, with files, you can navigate them. So you can get a list of the children. If the file represents a directory, you can get a list of its children simply by calling .children on it. But that capability, the capability of accessing the children, doesn't apply to an HTTP URL, normally. You normally don't have a good way of finding out what pages are sub-pages of a particular path at a URL. Streaming data between resources, this is another capability we might want, and this requires the ability to read from one stream and write to another. Slurping an entire stream of data, which is what we saw at the beginning. So we're pulling the entire contents of the stream into memory. This is sometimes a good idea because we know we've got a short amount of data. Other times, if the stream is very long, possibly endless, we really don't want to slurp it into memory. We'll get an out of memory error or run out of time. We might want to calculate an MD5 or an SHA-256 digest from a stream. And then basically we can, for any resource, and if I go back to the list of resources here, any of these can have any capability, provided it makes sense, and I'll explain that in a second. So, talking about streaming, in Java you have the concepts of a reader for reading characters, an input stream for reading bytes, writer for writing characters, and an output stream for writing bytes. But these are different concepts for very, very similar things. So in Rapture IO we have just the input type and the output type, but these are parameterized with either char or byte, depending on what we're doing. We can additionally have represent a line input stream as an input of the string. So our units of data that we're reading each time aren't characters or bytes, they're strings. And you can have any other kind as well. So you could define an input that uses ints, that has a concept of blocks if you're working with say blocks in a file system, or frames in video, or even something like XML tags if you are doing event-driven XML, for example. So these are all possibilities. None of these last three are in Rapture IO, but they're extensions that are there if you wanted to add them, if you have a good way of defining that. Yeah.
Another question. Sorry.
Go for it.
I don't want to be a troublemaker.
No, carry on.
Let's say I'm not experienced in new IO, Java new IO, but as far as I know, this is a mechanism that allows you to scan out, to search through the really huge files, yes? And if then are using something which is called DMA or something like that, I don't remember you can sense a window which the size is not even integer but 1. And here in this solution, there's also such possibility that I can, for example, read 10 or something.
Sort of. So the input and output operations work on strings. So this is typically where we're reading the start of a resource, and we read sequentially. NIO gives you more opportunity to do random access. So Rapture IO does not do NIO yet, but NIO operations would be another capability that could be added. I do plan to add them. Could be added later, but it wouldn't work with input and output objects. It would work with the channels and so on that are relevant to NIO. So that is a planned enhancement for later, and I've had that in mind from the very beginning. My experience of NIO is weaker than my understanding of streaming, so I focus on this first. But I certainly plan to add some of the asynchronous stuff later on. I hope that answers the question. Yeah. So Java compatibility. Now, I talked about some resources that Rapture IO finds. But the fact is that people who use Scala work with many different Java types as well. So how do we work with these? Well, we can just import everything from Java resources into our session and into context, and that allows anything in Java that has a getInputStream method. So things like a process. That then becomes readable. That means anything that any capability that Rapture IO has that represents readability. So slurping, streaming to another resource. That will work directly on a Java object, provided that Java object has getInputStream defined and that you've imported Java resources. So it integrates very nicely with existing Java code. And anything which has a getOutputStream becomes writable. So the combination of these two allows us to very easily mix existing Java and or Java IO, should I say, objects and Rapture IO. This is using structural subtyping. Who knows anything about structural subtyping in Scala? So not very many people. Okay. The basic idea of structural subtyping is that rather than defining a type in terms of a member of a class, you define a type in terms of its members. So what we can do is we can define a type, let's call it readable, and we can say def get input stream, which returns a Java input stream. We now have a type called readable, and anything that has that fits this definition up here, it has a method called getInputStream which returns this type. That is then a readable, and we can use that in any place that we want to. So we can rewrite a function like that, which will take a readable, and that will work with anything that has this getInputStream method. So this is how it's implemented in Rapture IO. Right, I'll show you some HTTP operations. So we can send a post to an HTTP URL. Now, an HTTP URL is written much the same way as a firewall URL is. we start with HTTP, we do slash, and then we do something like that. And I think that's the place we go to do a search. So we've then got this URL. I can then call post on that URL. And what I'm going to do is I'm going to post something to Google search page. Now, this method post is polymorphic in the value it takes. Now, what I mean by that is you can give it different values, and it will post that data in the appropriate way. Now, in most cases, what you want to do is you want to post form data, so you want to post keys and values. So the Scala type for doing that is a map. And we're going to specify a map that goes from the parameter q and contains the text "Hello World." Now, this will send the message over to Google to the page google.com/search with the parameter q equal to "Hello World," and Google will respond. I don't know if this is, if I have a feeling that Google don't accept posts anymore, but let's have a look. I'm going to slurp this again, and that's failed. If I check the status, it's a 405. So Google isn't happy with the particular post I've sent. It's not expecting people to be sending requests from command line generally. I might have missed a parameter or something, but generally speaking, you can send a map, and it will send that as URL form encoded. It will encode the parameter name, the parameter value. It will URL encode this, and it will send the appropriate line type. Now, the reason that works is this is important to discuss. The reason that works is there is a type class which defines how post should process a map. So the existence of this type class object, which in Scala is an implicit value, that allows the post method to know how to do a post to a URL. So we could define, for example, a means of posting, say, JSON objects as well, which sets the MIME type of the post message to application/JSON, or and encodes the JSON in the appropriate way. We could do it for any type we want, and it's simply a matter of calling res11.post, so our URL.post, and then the type in here. So if I were to send a string, it knows how to send a string. Google is going to be even less happy about me sending a random string of data to their search URL, but it's possible to do. And HTTP responses, so the type we got back here, again we're going to ignore the rest of this up here, but the HTTP response you get back, that is a resource, and it works like any other resource in Rapture IO. You can stream from it because it has the capability of being read. So, as an aside, if I know that this particular response doesn't contain any useful data, but if I were to take res15, I can stream that to a new file on my home directory, like that, up. This is unexpected. it's basically realised it's got two different ways of streaming this data. It can either stream it as characters, or it can stream it as bytes. So in this particular case, because I've imported the, I've specified the encoding, I'm going to manually say that I want streams as bytes. So I'm happy. Oh well, I'll fix that. I was making changes this morning. I just had quite a cool way of finding stuff through processes which I showed at the beginning. That didn't exist earlier. I've changed it through the process. Always a mistake. Anyway. So I'll talk a bit about how you would go about extending Rapture IO. Later on I'll talk some more about the JSON stuff, so if that interests you, there's more of that to come. So the idea is that everything is loosely coupled. We define resources, these are our URLs, our paths and so on, separately from what they're capable of doing. And any resource can have any capability, but only if there is a type class implementation within scope. So any HTTP URL can be read by virtue of there being a type class which tells Rapture how to get input stream from the HTTP URL. And all that does, that calls the methods inside jar.io that get that input stream. Now, an HTTP URL can't be written to generally, but say we had a magic way of writing to an HTTP URL. Maybe we're using WebDAV, or maybe we're using FTP, and we had a way of writing that. All we need to do is define a type class which allows us to write to the HTTP URL, and suddenly that HTTP URL has the capability of being written to. We can stream data from our file system to the HTTP URL simply by using the angle bracket symbol as I did before. So implicits and type classes are absolutely fundamental to make this work. How well do you all understand implicits? Really? Oh, sorry.
Or not.
So, who's used implicits? Good, okay. So I'll talk a bit about implicits because I've assumed that implicits and type classes are well understood. So I'll show you an example of an implicit. If I have a function called foo, which takes an integer, if I want, I can return that integer x. This is a really boring function, and I can. It's just starting basic. So foo 10 gives me 10. Great. Now what I can do is ask for an implicit parameter as well, which I also want to be in this particular case. And what I'm going to do is add x and y together. Okay, so you've got a new definition of foo. It overrides the old one, so that can be ignored now. Now if I run foo of 10, this will complain because it doesn't know what y is. Now I've got two options here. Either I can specify what y is, like that, and it's perfectly happy. It's as if this value here wasn't marked as implicit. But what would be nicer is if everywhere I've got an implicit value of y, for this foo to work without me specifying it. So I want to be able to just write foo 10. So I'm going to say implicit val y is 32. and then I can get rid of that. And what the compiler does is it says, we're calling foo, it takes the parameter 10, great, there's the definition up there. But it's asking for an implicit y of type int. So it looks within scope, and the definition of scope is quite complicated, but it basically means that you can access something of that type. Yeah?
So how are implicit scopes? So if the thing that I passed into this function was a callback, right, or something like that, and it was then passed around to some other library and executed later outside.
So you mean if instead of doing a value y, I did a def of y, which I don't know, did math.random times 100, like that, which possibly accesses another library.
Mm-hmm. So, no, I mean, I understand that it's called the y, when you set it using implicit,
Yes.
it will be, the value will be set within some scope.
Yeah.
But you could define, let's say, a callback or object that accesses this y in some way, right? And
where are you doing this definition?
It's down in compile line. If you
okay, so essentially, I'm asking because in Clojure there's a very similar thing called binding, and you have to like sort of worry about that a little.
Oh, okay. So the way it works in the compiler is that it sees that foo is taking, or foo in all cases needs to take 2 parameters, and the compiler must choose 2 parameters at compile time. So all it does is it makes a reference to this this type y. So I've defined my implicit def y here. So this will now give different value each time, as I'm adding effectively 10 to a random number less than 100. The compiler is it's simply compiling into this method call 2 parameters. One is fixed, one is 10, and the other one refers to the implicit value, which is within scope somewhere. And within scope means you can access the value like that, effectively. So that's a very basic use of implicits. We can also do something a bit more complicated. So, who's seen type parameters on methods? Okay, good, yeah, most of you, I think. So we're going to find a type T, which takes I'll keep my x value there, but y is going to be instead a list of type T. And what I'm going to do is I'm going to just return y. I'll keep it very simple here. So what I've said here is I'm defining a method that has a type parameter in addition to the value parameters, and we're going to look, or the compiler will look for this implicit parameter again, but the implicit parameter is dependent on the type parameter t here. So depending on what I specify for this t will influence which particular y gets resolved. So let's demonstrate this. I'll create list 1, which will be some integers, and list 2, which will be a list of strings. So these are both within scope. If I call foo, I'll give it x, and I will specify the type parameter string here. This gives us the string, so it's resolved list 2. because I asked it to get string, T is string, implicit Y is therefore a list of string, and there is a list of string in scope. If I said food int, it will fetch the list of integers that I specified. If I don't specify, then it doesn't know how to choose between them, so it will remain. So if there's any ambiguity, the compiler will tell you and force you to specify. So that's the kind of the foundation of type classes. And what we can do is basically request an implicit that's within scope, and scope in terms of Rapture IO means it's in the library. So when we import from Rapture.io_, that basically gives us all the implicits that I've defined that will do things like stream to HTTP URLs, to files, and the methods like slurp take these implicit parameters. They take the one that's most appropriate for the method call. I'll just show you one more cool thing actually. If I redefine foo again, and I don't say x is an int, I say x is a type t. What I can do is call foo of 1 without specifying the type. And what the compiler does is it says basically we've provided this with an integer. That must mean that t is an integer. So we start with the parameter, it resolves the type to being, it resolves t to being an int. T is an int, therefore we're looking for an implicit y, which is a list of int, and it finds the appropriate one. Likewise, if I make it a string, then it finds the string. So this makes it very neat to be able to define capabilities. So a capability is a type class in many ways. It provides the means of dealing with some kind of type, or in the case of Rapture IO, a resource. So that was a very brief and almost certainly too fast discussion on type classes, but they're absolutely fundamental to Rapture IO and the implementation. So if you get a chance to read about them, I strongly recommend it, because it allows you to do a lot of things in Scala that would otherwise be very difficult. Any questions on that? No? Okay. So the point I was making earlier is that the definitions of the capabilities and the definitions of the resources are very loosely coupled. And the bridge between capabilities and resources are these type classes. So they provide the implementation of a certain capability. So what we get as a result is this very natural API where if we think a resource ought to have some kind of capability, then there's probably an implicit define that provides that capability, and therefore it will just work. So this point here that a simple type class implementation can provide a lot of functionality. What that means is, if you define a way of reading a resource type, for example, so we've defined, or Rapture defines how you read a file, it defines how you read an HTTP URL, it defines how you read from a socket. Simply by having those definitions, and they're very short definitions, they basically get the input stream from those particular resources. This then allows you to do things like slurp, calculate MD5 checksums, SHA-256 checksums. It allows you to pipe it into a process, all the streaming stuff, either as bytes or as characters or as strings. This all comes from just one definition. So, if you were to, if you wanted to add a capability, for example, A method like, I've explained this in the type class discussion, but slurp, for example, takes a type parameter. The examples I showed before were either byte or char. This looks for a type class called stream reader. So it says I want to slurp characters, then I need a stream reader for dealing with characters, which is the type T, and the type of the object being slurped. So if I'm doing HTTP URL.slurp char, it needs a stream reader which has two type parameters. One of them is char, one of them is HTTP URL. And if one exists, which and one does generally, then it's happy to do that. If it doesn't exist, then that's not possible. So here's a definition of a type class for reading processes. Proc byte input. We simply define a new stream reader. These are the two types. We're doing bytes, and we're giving them out of a proc class. And it only needs one method. It needs the method input, which takes the proc and returns the route into the stream from that process. I could spend a little while on this example, but it's probably not worth it. It's not particularly interesting. But with this simple definition here, every instance of a proc, which was, for example, my call to grep that you saw at the beginning, that then has methods like slurp and streaming. There's an even easier way. There's a convenient way of writing exactly this using Java and stream reader. So if you had your own particular type from Java, then the easiest way would be to specify the simplicity here. Probably a bit short on time, so I won't talk too much about resources. Resources are the most, they have the fewest constraints on them. So basically anything can be a resource, and we can leave it at that. So encodings, who knows anything about character encodings? Who's had bad experience with character encodings? So more people have bad experience with character encodings than have any experience of it. So, can anyone read that? This is Google Translate. I don't know what it is. But we have these additional characters here that you wouldn't expect to see. I don't know, is it possible to actually understand what that says? Yeah. So
only one spelling error.
Oh really? Okay.
Yeah. The last letter.
It's a grammar error.
Grammar error. Yeah.
But additionally, we've got these A's with unwraps on, which we don't really want. What's happening is UTF-8 encoded data is being interpreted as Latin 1 in this, or ISO 88591 in this particular example. So Unicode is a multi-byte, or a character could be represented by more than one byte, whereas ISO 88591 has strictly 1 byte per character, and you get this mess all over the place. What's basically happening is software is making an assumption. It's making a false assumption about what encoding is being used. And often, or in pretty much every single character encoding, ASCII, which is the first 7 bits of the character, the first 128 codes. That's the same in any character set. So it's easy not to notice if you're only working with ASCII text that doesn't use any characters that are unusual. Though the definition of unusual is probably different in Poland than in Britain. This problem happens more at home because Unicode and Latin 1 are identical for 99.99% of all text that we'll see. So it is an issue, and I think a lot of people go a long way in software development without fully understanding encodings, and I think it's a bad thing. So in Rapture IO, it makes no assumption about what encoding we're using. I'm forcing you to decide on your encoding and specify it. So this is done using the implicit value. So any method in Rapture that needs to know encoding, which includes things like converting between bytes and characters, that will expect an implicit, it will take an implicit value, which is encoding, and I've specified here, for example, UTF-8, but any encoding that stands in Java is available there. So there's a lot of other useful stuff that's been bundled into Rapture IO. There's probably not time to talk about it in any detail, but I'll quickly run through it. If you want to encode stuff as base64 or as hexadecimal, there are encoders and decoders available. There's some security stuff, so AES encryption, various digests and HMAC signatures. There is a list of MIME types, which is several thousand lines of code long, but it gives you a mapping between, or it gives you a type-safe list of MIME types that you might want to use. And backings to file extensions. This is useful if you're running a web server where you need to serve a file and you have 3-letter extension at the end and you want to know what MIME type to serve that in. Unfortunately, that's there's no particularly good way of doing that apart from listing all the different possibilities. There's quite a neat command line interface path. So if you're writing a command line app that takes parameters and takes flags, this will allow you to parse that simply by extending a subclass of the app trait. So instead of writing an application where you subclass app, you subclass called CLI app, and you have access to the command line branch that you might pass into your program. There are objects representing IP4 addresses and doing things like working out subnets. There's a method for sending an email, and there's this is work in progress, but there is a few methods for dealing with time, immutable time and date values, and money and currency. So I'm probably running out of time, aren't I?
I guess we have 2 more minutes.
Can I take 10?
Yes, you can.
Okay. I'll try to be quick.
We can start a little bit later, so that's okay.
Okay. So, Jason, who's worked with Jason? Great. So you know what it is, you know what it looks like. So we're using the new dynamic trait in Scala 210 to access JSON. That was what I showed you at the beginning, where you simply parse a JSON and you can call dot and any method name, and it won't complain at the compile time. So because the type is JSON and because JSON implements the dynamic trait, that's saying to the compiler, actually we don't care about type checking with this. Just go with it. We'll worry about it later. So we skip type checking at that point, and this is all stuff I've shown you. And likewise, arrays. Any JSON type can be assumed to be an array. I mean, it might be. We don't really know until runtime whether it is because we've got no static checking of the JSON structure. But you can stick parentheses after it, stick a number in, and that will get you the nth element of that array, if it's an array. And finally, at the end, you call get type, and that will tell the Scala compiler that we're satisfied that all those dynamic stuff is finished with now, and we're going to work with the final type. There is unfortunately a bug in Scala 2.10.0, which means that we can't string together a sequence of value lookups with gets at the end. Unfortunately, it gets it wrong, but and you have to do it. You have to split each line into 2 lines, which is it's a pain. But Scala 2.10.1, which is coming out soon, I think, in the next couple of weeks, if it's not already out, does fix this bug. So we can read JSON. We also want to write it sometimes. So this is familiar for anyone who's used JSON in Scala. It's similar at least. We define equivalent types or we use the equivalent types in Scala to represent the structure. So we've got list and map here. And we just wrap that in JSON. And what that will do is give you the appropriate JSON from that. But if we wanted to embed directly into our code the JSON, we define a special JSON string. This is another Scala 2.10 feature, which you might have seen string interpolation, where you can reference variables inside a string. For JSON in Rapture IO, you simply prefix the string. We've got a multi-line string with triple quoting around it. Prefix it with JSON, and anything in here gets parsed as JSON. And it does in the same way that string interpolation works. We can specify a value as well. So this is a JSON object. It has a key called greeting, and the value is going to look up from the Scala code around the value called x, which is hello world. And that's a string, so it knows that it's going to display it as a string. If x were an int, then it would include the int appropriately. So we can go one step further than this, and we can pattern match on JSON. This is really cool. So here's an example. I'm going to try and get you to understand this because it's worth looking at. First, look at the first line to begin with. We're defining our source, which is some static JSON, just a string at this point. It's a JSON map which contains 2 values, y and x, which both have ints. Now, what we're going to do is we're going to parse that, and we're going to try and match on the results. So, inside our match block, we're going to define the matcher. Now, this is the same JSON string, or same kind of JSON string that I defined here. In this case, we're creating a string. In this case here, we're going to try and extract data out of that string. So this is basically saying that from parsing this source, I'm going to expect a JSON map with 2 values, x and y. And I've put these placeholder values in here, $x and $y. Now what it's going to try and do is not only parse this and check whether we get a JSON map of the appropriate type, but it's going to try and pull out the values of x and y. Okay? So available for us to use here are x and y, which come from this x here and this y here. We need to get integers out of them because remember it doesn't know, it's dynamic, it doesn't know what type they're going to be. So we're going to get int from x, we're going to get int from y, and we'll add them together. What's the result of this? And then also 42. Good. And this works with even deep structured nesting of JSON. If it's first of all, it has to match the structure, so it'll filter anything, it can filter out anything that doesn't match the JSON structure, and then it will extract these free variables out of that structure. If it doesn't match, then if it doesn't match the structure, then you won't get a match. So I did promise to talk about the those funny return types you saw in the record right at the beginning. I'll do this quickly though. It's quite a complex topic, but the problem we have often is that sometimes we want to do things really quickly. We want to do simple scripts that might throw an exception, but if it throws an exception, we don't care too much. We just let it happen. Or we stick in a try and catch block, and it doesn't matter too much. But at other times, we want to build very safe software that deals with any exception when it happens. Which means you have this duality. It seems like we actually want two different APIs. One which returns the raw type and fails with an exception, possibly. Another which returns a very safe either. So either in Scala is a bit like option. So option is either some or none. Either is either left or right. But the difference between either and option is that either both left and right take values, whereas option only some takes a value. So either represents one of two different kinds of result. And the two different kinds of result we might want to get from an I/O operation is either a success, so the operation did what we intended it to do, or a failure, which is an exception. What we don't want is for the exception to be thrown. We want to have it in a value that we're forced to process. So what Rapture does is it provides the entire API, that's every slurp method, every streaming operation, with two different personalities. One of them is the exception thrown version, and that's the one I've been showing you largely today. The other is the very safe version, which will return, in all cases, either left of a failure or right of a successful return value. So if, to give you a more concrete example, if I were to try and slurp a file on my file system, and that file didn't exist, we would get, as a result, in Rapture.iox, not in .io, we would get left of file found exception. If I specified file or tried to slurp a file that did exist, I would get right of the contents of that file. In Rapture IO, you either get the data straight out, you get that string or array, or it throws an exception and you suffer the consequences of the exception being handled or not. There is another possibility, which is to return a feature. So the difference between both IO and IOX and the future version is that the future version always returns immediately. So as soon as you send the command off, you get a feature straight back, no blocking. And it might at some point complete. You can decide to wait for it. But that is, yeah.
Which future implementation? Windows, yours?
No, it's the ACK one, so the one that is in Scala 210.
Okay.
But there would be nothing to stop you implementing Twitter's or anyone else's. And in fact, back to my earlier point about as a programmer, you should only encode the differences between two things. That applies particularly to this idea here. It would be completely unmaintainable for me to have two different, or three in fact, versions of the entire API with different return types. So I do something quite clever with high-kinded types, which basically does it all for me, and I specify about 5 lines of code for each different version. So to use Twitters, for example, you write 5 lines of code, and it ought to work. But the neat thing about this is if you're familiar with one personality of the API, because it is really the same API, I'm only maintaining one version really, you are automatically familiar with the other, except for the bit that differs, which is the return type. I wrote an article for the the Software Developers Journal, it's a mistake there, which is on Scala this month. There's quite a long detailed explanation of how that works. So if you wanted to implement your own API that has different personalities for different purposes, then read that. So very quickly to wrap up, because I'm way over. Rapture IO, which is this website here. You can find out a bit more about it there. There's some documentation and various links. If you use SBC, then just include this string, and it'll be built into your project. You can get the source code on GitHub. It's under Prepentative. It's called Rapture IO, and it's available under Apache too. So it's free to use. So where next? I mentioned before that I want to have non-blocking I/O support. I think this is the future of I/O is in non-blocking, but it is a different programming style. So I'm going to add capabilities to support this. More documentation. There is some documentation at the moment, and there's resources on the Rapture IO website that will get you started. There's a getting started page that will help.
There's always not enough documentation in all of the products.
I'm trying. I'm going to do more testing and get started on performance benchmarking. And if anyone else thinks there's something that ought to be in Rapture IO, please talk to me. I'll be available at the end, and very happy to discuss ideas. And just say thank you for having me. And if anyone has any questions, fire away.